My name is Raj, and I'm the product marketing manager here at Rendered.ai. I'd like to introduce you guys to my colleagues. You guys just heard from Tom, who's the head of customer engagement here at Rendered.ai, and he's an experienced enterprise sales executive, formerly at Kymeta, Glimpse, and VoiceBox. Dan is the lead solution engineer here at Rendered.ai and has 10 years of experience building geospatial solutions at Esri and elsewhere with a focus on remote sensing, 3D data, and geo AI. Today, Tom, Dan, and I will be presenting an introduction to synthetic data in the Rendered.ai platform. Just a little bit of housekeeping before we get started. We are recording the presentation, so you will have access to this later. We'd love to hear from you, so please feel free to drop any questions in the chat. We'll be monitoring the chat throughout the presentation and have some time scheduled at the end for a Q&A session. I'd like to quickly run through the agenda of what we'll be covering here today. We'll be defining what synthetic data is, outlining the value synthetic data brings, introducing the Rendered.ai PaaS, and going through a quick demo. And finally, as I mentioned earlier, we will have some time at the end for a Q&A session.
Hi, Hera. Does PaaS mean platform as a service?
Yes, Tom, exactly that.
So when you say platform as a service, are you saying that no two but possibly closely related applications are exactly the same?
Yes, exactly.
So help me out here. You need a platform with the plumbing and the integration points and the feature set to solve a specific problem with a general tool. And Rendered.ai is a platform as a service for synthetic data, which means, I think, custom synthetic data solutions on a generalized platform. Did I get that right?
Yes, exactly. You got it right.
Fantastic. So I have one of the coolest jobs in the world. I enormously enjoy my job because I get to see both the customer pain side of doing artificial intelligence and then really interesting ways in kind of how to solve these particular problems that one might have. I'd like to show you a quote from the Army that came out last October. It was in something called a SIBR, which is just their request for proposal. And this, I commend the Army for their candid, honest appraisal of the state of the art, and that I applaud them for taking such a succinct and good view of what they see as being the major problem in their data sets. And let me quote here. There is not enough unique defense intel data available to create performant models. Wow, that's an amazing statement. And then they go on to say it takes roughly 50 million pieces of data to create a 60 to 70% performant model. Okay, 67% is not all that good, and 50 million is a very, very large number. Additionally, this data set must be labeled. So you must have humans going through and labeling. So let's break apart this problem for a minute. If you are collecting the same information over and over and over again, you're not picking up the diversity, you're not picking up the variation, you're not picking up the atmospherics that change, you're not picking up the color variation, the placement variations, the 3D background variations, all of which make it so the AI can recognize their targets when their targets are not as expected. If you're flying the same satellite over 4 times a day and taking the same picture, you may end up with 50 million pieces of data, but it's not 50 million pieces of data that's particularly helpful or useful. And to the point, all that stuff needs to be labeled and labeled by humans as opposed to synthetic data that is labeled by a machine.
So what you're saying, Tom, is that customers don't need more data, they need better data.
Absolutely, Hera, you got it in one.
Data is a critical limiting input for AI, and this is especially true if the objects or events you need to detect are rare in nature. If you're relying on images of white elephants to train an algorithm, then you simply won't be able to find enough real photos for training and validation. Similarly, AI capabilities are limited when data is scarce, as is the case in many novel applications. Data can also be very expensive to annotate and can introduce errors when conducted manually. This is especially true in cases where data isn't easily interpreted by humans, as is the case with complex sensor types. Finally, the datasets required to train models often contain information that is secure or private, making data acquisition all but impossible. This is why the current linear workflow shown here of acquiring data, training that data, testing the algorithm using that data, and accepting or rejecting the result is highly ineffective and can lead to barriers in innovation. It is time to take a different approach. As Tom mentioned earlier, the reality is that well-performing enterprise AI needs a solution to reduce cost, bias, and enable innovation. And that solution is synthetic data. We define synthetic data as data that is engineered using algorithms or simulations, which can inform an AI model about features present in real data. We use this definition because we find that it's the most effective approach in addressing the problems that our customers are currently facing by bringing in diversity, with the goal being to make data authentic enough for an algorithm to believe it is real data. Obviously, we think synthetic data is really important, but we aren't the only ones. In fact, VentureBeat noted that 89% of tech executives see synthetic data as a key to staying ahead. Organizations that fail to adopt synthetic data are at risk of falling behind the curve. Furthermore, Gartner predicts that by 2024, 60% of data used for AI and data analytics projects will be synthetic. And by 2030, synthetic data will have completely overtaken real data in AI models. The growth potential is evident, and those of you working with vision data are best placed to take advantage as you understand the value of vision data and how it can benefit your industry. We can already see synthetic data taking over the autonomous vehicle industry.
What's really interesting about this slide and those stats that you have here is that you look at VentureBeat and they say, hey, we think this is going to be important. You look at Gartner and you say, hey, we think synthetic data is going to be important. This is the world that Rendered AI works in every single day. And we know the value of synthetic data. I don't mean to sound that braggadocious, but it just says that this is a world of problems with AI deep in the basement of where the data sets are. And synthetic data is one of the great ways of solving problems like the Army problem of the data sets and making them more relevant. The autonomous vehicle industry has done a great job, a spectacular job with synthetic data. And they're one of the truly great poster childs for creating synthetic data in order to have a really good application. But I want to tease out how they're different than what we're doing with at Rendered AI. What they're doing is having a highly focused boutique point solution to solve an autonomous vehicle training problem. Great. Love them. It's terrific. But what we're doing is creating a generalized platform. And that platform allows us to have the flexibility to solve not only today's problems, but be able to anticipate what tomorrow's problems might be and put them into our data set. So we're taking a generalized approach to this problem as opposed to a point and specific. It gives us better diversity. It gives us better ways of working our data sets, and all over a better solution at a much lower cost than these high-end synthetic data solutions for autonomous vehicles.
Unlike today's AI workflow that we saw earlier that is linear and relies on finding or acquiring data, Rendered AI's workflow incorporates synthetic data in a closed-loop workflow. The value of the closed-loop workflow is that it's inexpensive. There is an opportunity for unlimited data generation with 100% accurate labeling, where real data sets are used for comparison and post-processing, and data can be designed for edge or impossible cases and to remove bias.
I'd like to get philosophical here for just a second. One of my favorite authors is Stephen Hawking. So he wrote A Brief History of Time. And if you followed A Brief History of Time, one of his seminal ideas was that you can't remember the future. That's why you know time is linear. And it's kind of a profound thought. It's simple and profound at the same time. So what this means is that you saw in the beginning of this presentation, I showed you, we've made tens of millions of images, and that we have all these different applications. We have remote sensing and supply chain and automotive, and that the generalized platform can do that. But let's say you're focused on Earth observation, and that you have an Earth observation problem, and you have a great sensor, as Hera was pointing out, and you have a good data flow, and that you have this work that you're doing, and you realize, I have the wrong model. I need a different model. I need a different characteristic in the way I obfuscate my model. I need to put it in a different background. I need to do something different, like the Army needed to do something different in order to make their data sets work. And that's the power of the platform, and that's the power of the words from Stephen Hawking saying, you can't remember the future, so you have to be able to be flexible around it.
As Tom mentioned, the power of the platform is that you don't have to rebuild everything for every AI application. Rendered AI provides standardized infrastructure to create and manage synthetic data pipelines. This allows for innovation that you haven't even anticipated and access to synthetic data as an enterprise capability. On that note, I'm going to hand things off to my colleague Dan, who will walk you through the platform.
Great. Thanks, Hira. So Hira and Tom kind of introduced the idea of synthetic data, showed it its value, talked a little bit about a platform approach. And I'm going to get a little bit more into what that actually looks like and why we need a platform to solve the problem of synthetic data. So when people get into synthetic data, when they're thinking about it for the first time, they're often thinking about it like this. So we have a simulator. It's a really great simulator. It creates a data set. We plug it into the AI model, and all is good. But we're finding that that doesn't really work, and it's a little more nuanced than that. And really, what we're finding is this is the workflow that it provides results in the real world. And it's like Hira and Tom mentioned, it's more of a cyclical thing, and it allows for more capabilities that allow for improved outcomes and explainable outcomes. So I'm going to get into each piece in this workflow and what it means, why it's valuable, and why you need a platform to solve it. All right, so the first question you have when you're generating synthetic data is synthetic data of what? What am I looking at? What am I looking for? So in a simulation context, we start with 3D models of what we're looking for. So this is just a picture of the example channel. So if you sign up for a free account with us, you'll be able to play around with dropping toys in a box procedurally. But we're starting with these 3D models to get a sense of what these objects that we're looking for are and how they exist in their world. Some complexities there you need to think about are material properties of these things. So that could just be textures that are applied if you're looking at something in the RGB space. If you're looking at a more complex sensor type, you may need to account for roughness, smoothness, things like material type, and then the ability to potentially do dynamic posing or change the form of your model in various ways to get the right amount of context for them. Then you also have to think about distractor objects. So you've got your objects of interest. You want to make sure that you can differentiate those objects from other objects that are similar to them. So if you're looking for school buses in your computer vision model, you may want to add in some city buses or some fire trucks, things like that, to make sure that the model's really picking up on the features that are unique to your object of interest. Then you need to think about what is the context for your data. So you may be able to pick out a plane on a tarmac, but what if you need to identify planes when there's obstruction or various other features that may get in the way? And so this concept is very important to domain randomization, and it's allows us to prevent overfitting of our model. And then these backgrounds can really vary in complexity based on the problem at hand. It could be a catalog of 2D images that you place your objects into, or it could be those sort of high realism 3D generated procedural models of cities or various other scenarios, industrial sites, things like that. So it really depends on your application, what you're trying to do. But the platform will be able to kind of allow some flexibility, and what sort of backgrounds are you want to put in here? What kind of context are you looking for? And then we get to our sensor. So the sensor is a very important piece because if you think of your AI model as the brain in your computer vision system, the sensor is your eyes. And right, so eyes are very important to vision, and you want to make sure that you get those eyes correct so you can understand what you're seeing and how you're seeing it. So whether it's it's a high resolution drone image or a lower resolution satellite image, if you're looking at something in infrared or synthetic aperture radar, you want to make sure that you capture in a high fidelity way what you're looking at and what the sensor would detect in the real world. Environmental effects affect how we see. So making sure that things like dust or clouds, things like that are properly captured. And then because there's many sensor types and we can't be the purveyor of all high quality sensor models, you really need to be able to integrate with the best simulators on the market. So for basic rendering, we plug into Blender or NVIDIA Omniverse Kit to be able to do that rendering. For more advanced types of models, we have some of our own proprietary models, but also we plug into things like DeerSig. So for high fidelity remote sensing simulation, QSim for things like X-ray simulation, and we're working to grow that partnership as holistically as possible to make sure that all these different scenarios are captured and we can provide a variety of different simulators. So that's another important part of having a platform, being able to tap into all those different simulators. And then if you've got, if you're simulating 3D models and worlds with physics-based rendering, processing can be intensive. So and speed is important when we're thinking about synthetic data. It's important because we want to be able to iterate and experiment with different scenarios and see how that affects our model. And then once we have a set up a simulation pipeline together, we want to be able to produce those images at volume, right? So 10,000 images. We want to be able to create that without waiting weeks. So managed compute is an important piece of that, and the Rendered platform manages all this setup, breakdown, scaling of the cloud compute in platform. It takes care of all the costs, takes care of all the complexities there. And then once you get your data, this type of experimentation, it requires a level of librarianship that allows you to differentiate between what you were doing before, what you're doing now, how it's all controlled. So we approach that from a cloud-based data set management perspective. So you can access all these different data sets within the cloud. You can provide descriptive names and descriptions to them to be able to track all these different things and do queries on what types of data sets you're looking for. And then really one of the major major value statements that synthetic data brings to the table is this flexible annotation. If you want to change your annotation type from bounding boxes to semantic segmentation to instance segmentation to panoptic segmentation, you can do that with a click of a button. You don't have to send this back, your data back to a team of technicians to be able to, that will have to, spend weeks and thousands of dollars to be able to re-annotate that data. So next, once you have your data set, you're not necessarily done, right? So you don't necessarily just plug it into the model and be good to go. What we're finding is that there's a lot of value in being able to do domain adaptation on your data set using domain adaptation neural networks like GANs. So the cycle GAN approach is something you may have heard of in changing pictures of horses into pictures of zebras. But what we're doing with it is a little bit more discrete. We're using it to bridge the reality gap in simulation. So often you can't get a perfect representation in your simulation of exactly the sensor type that you're looking for. But if you train one of these models on your real data and apply it to your synthetic data, it will kind of do a lot of that recalibration automatically. And then quality assessment. So the gold standard is how much it improves your AI model. But we have some other tools to be able to assess feature richness, to be able to really get a sense for what's going on in our data and get some more information about its quality. So things like UMAP comparison. So this is a form of dimensionality reduction that picks out the different features that object detection model will find in your data set and compares it with your real data set. So being able to compare features found in a synthetic data set versus your real data set and find those outliers where your synthetic data might not be capturing those. And then we can look at spatial attention maps to be able to pick out within those outlier data sets what exactly those features are that we're looking for. So if you have a synthetic data set that does not include vehicles, one of those outliers may be picked up on a car, or it may be picked up on a tree that has lost its leaves, whereas you only have full trees with full foliage. So you can kind of look at those and think about, is this important to my model? Do I need to be able to capture this in my synthetic data, or is it kind of superfluous? Then the AI model really closes the loop. So it, like I said, gold standard is to be able to show improvement. And then you can also identify areas where you may need a little bit more improvement and be able to go back in this loop to iterate on that a bit more. So this whole loops really provides a new set of capabilities to AI. And those capabilities provide these improved and explainable outcomes through reduced data constraints, new ways to experiment with our data and with our AI models. And it really allows for a provable AI. So what experimentation, what hypothesis, you can try these out, test, and then see the results and in a provable way. So you may look back at this and say, if you're a data scientist, that's not necessarily my job to go in and work with 3D models and procedural world generation and simulations. And we agree with you. So we built this platform with the data scientists in mind, but in doing so, we kind of learned that there's a whole other role involved here, and that's the synthetic data engineer. And if it's true that synthetic data is going to be and we think it is going to be one of the most important pieces of AI going forward, we really think that this is going to be kind of the job of the future, and it's going to be someone who has that domain expertise in simulation and different types of sensors, renderers, and things like that. Is more software development oriented. So we've developed this. If we go back and look at this workflow, you can kind of see where those different pieces come in and where the platform comes in and covers those different pieces of managed compute and things like that. So the synthetic data engineer is really setting up that pipeline, what we call a channel in our lingo. And then the computer engineer is kind of driving that pipeline, configuring it to improve the model scores and statistics. So when we were building the rendered AI platform, we took both of these roles into account. So we have a flexible open source framework to be able to create these channels, these pipelines, and as well as an open SDK to be able to integrate these with other systems to be able to provide flexibility. And we have a full set of developer documentation to be able to work through those different tutorials and things like that to get a sense for what this looks like. Then on the other end, we have, once that gets deployed, we have a no-code web interface. So you can configure the pipeline, the graph to to your needs and to be able to experiment with that. And then that also has job management, the cloud-based dataset library, and then those post-processing microservices. So with that, I'm going to jump into a demo of what we're looking at here. So let me jump out of this and share my screen here. All right. So this is the Rendered AI web page. And you can kind of go through and learn about our offerings here. But once you're ready to dive in, you can go up here to sign in. And if you don't have an account with us, you can go here and request access. There's a free basic account that you can work with. Sign in here, and that takes you to your organization. So within your organization are these different workspaces. So each workspace is kind of an organized set of your pipeline to be able to generate synthetic data. It has all the job management data set capabilities in there. Then you can go ahead and invite other members here. So if you have other members that you within your organization that you'd like to invite, go here and invite members. But if we go back and look at it, so these are these different channels, these different rendering pipelines that we've put together in these different workspaces. The question that I've got right now, so I want to find out where in the world, based on satellite imagery, their construction is happening. So I can go in here and into my satellite RGB workspace here. I can create a graph with a title for that and provide the channel. So remember that channel is our rendering pipeline that we've enabled here. When we create the graph, we can go in and see exactly what that looks like. So here are our nodes in this graph. We've got objects here. So this is a mobile crane here. We've got a clustering algorithm that places those cranes within our scene. We've got a set of backgrounds. So this is kind of that simple catalog of 2D areas, 2D scenes that we can place our cluster and place our objects within. Then we have our sensor model. So this has various various parameters for the sensor, so look angle, azimuth, things like that. If we want to vary those, so there's certain things that we want to keep consistent, right? Because we want to model what's going on with our sensor. But if we want to vary certain things like look angle, we can add in a random number generator here. So we can go between 1 and 15 because that's kind of the tasking of our satellite here. And then for every run, that'll generate a random number between those values. We can then go in and add other objects. So we've deployed a number of other objects. If we want to add in some other tower crane models here, we can do that. Add those in, plug them into our clustering algorithm here. Do it one more time with one other. Get the diversity that we need. So within each of these, we'll generate a different set of tower cranes, things like that. And then once we're all happy with what we've got, we can stage this graph, and that brings it over to our jobs pane. So our jobs, you can see jobs that have been created in the past. Here's the graph that we just published here. So we can update the name. We can give it a description, and then we can specify the amount of runs. So every run generates an image. So if we want 100 images, we can put that in. If we want 1,000, flexible. And then we can also set, so by default, this creates an generates this automatic seed generator. And that's what feeds into that random number generator. So it works off of a seed to create random numbers. If we specify a specific seed number, we can control between different runs what random numbers get generated. So we can control essentially the generation of these images between different runs, and the change that we make to one graph, that will be the only change that is that we see between those two different data sets that we create. So that allows for a level of experimentation that you can really get a sense for exactly what differences move the needle in what ways. So then once we're set here, we can click run, and that'll jump up to our jobs pane over here. So just like in a cooking show where they put the bird into the oven and then have one ready to go, I've got another a data set like this ready to go, of course. So here's our set of cranes. We can see there's a lot of cranes in that one. Might not be very realistic, but it's we're training a model for these sort of edge cases. So we've got a data set here of various different cranes with their shadows applied based on the specific time of day in these images. And then we can generate a variety of different annotations. We've got some default annotations that come with it, but that's all customizable here with this annotation microservice. We can apply our trained GAN data sets here. And then once we're set and we want to load it into our model, we can either run an SDK call to pull this from the cloud, or we can download it down to our computer directly here. So we can go here and look into what's involved in here. So we've got our images, which I just showed you. We've got annotations. So these are in JSON format. They provide information about the location of all the different objects of interest in your image. And we have masks. So these are images that contain pixel values that correspond to what different objects are in your image as well. Then we have metadata as well. So what about that run, you can find all the different values and things that were used to produce that specific data set, specific piece of data. So with that, you've got everything you need to plug it into an AI model and get going. So with that, I am going to bring it back to the slides here. And I will hand it back over to Tom.
Fantastic. Excellent demo. Could you move me? I think I'm at 27. That, by the way, for those of you watching, know that this is live as opposed to being canned, because we're going, yeah, that's the slide we need to be. Welcome to live TV. I'm going to pull this all together in what we've seen in both Dan's demo and Hira's talk, and that use as a platform to talk about this, an engagement we did with the NGA and Orbital Insight, and with Rendered AI acting as the synthetic data engineer. So we were acting as a synthetic data engineer. We were creating the application. We were creating the graphs that you saw. We were working the system there. Orbital Insight was working the computer vision side of this. And of course, the customer is the NGA. If you have any questions about this, we have a white paper that's been approved for public release that I'm happy to make available to you just by dropping me a note here. But I'd like to bring this all together and talk about the issues that we saw in here and why synthetic data is so critically important, why this is a very good proof source for doing just that. Bring you back to the Army issue, and that was, hey, we don't need more data, we need better data. So in this situation, we were improving the data set. And the platform lesson, Dan and folks like him create these, the platforms, create the objects, create the thoughts here that allow us to go through this iterative process and improve the scores. The analyst saying it's important, and I think this is establishes the fact that here we have a case where it shows how important it actually is, and the engineering approach where you do it, you repeat it, you tinker with it, you experiment with it, and then you do it again and say, why did we move the needle and how did we move the needle? So let's talk about this for a moment. We have these crane trucks, tower cranes, mobile cranes. There were fewer than 100 examples in the original data set of these. Not 100 times 3, but 100 divided by 3. So we had some of them, we were dealing with 10 or 20 examples in the wild of what we were trying to look for. So people like Dan who work for Rendered AI built models based on this in order to say, this is the sort of thing that we're actually looking for. Then we had to create a world building. What kind of backgrounds are these in? What kind of, is this rural? Is this urban? Is this suburban? Is this a construction site? What kind of area are we actually looking for? Then we had to choose the simulator. Then we had to do the managed compute in order to create it. Rendered AI built all of this so that the folks from Orbital Insight could then take their AI model and say, if we change this graph, remember Dan was working on that graph there and said, if we change this look angle, what's the effect that that has? How does that improve our score or not improve our score? And then being able to do those quality assessments and being able to say, we have data that's sitting outside here for some reason. We should be looking at why that data is sitting outside our main target area and see if we should be including that in inside the model. Then looking at the average precision scores of what that meant. Okay, so think about our Army problem where they had to create 50 million pieces of data. In our case, we start out with just a few examples and models, and then notice how Dan said, I want 1,000, 10,000, 100,000 pieces of synthetic data, each one being subtly different because it goes through that graph in a subtly different way with different priorities. That creates a huge amount of diversity, and it's all being created extraordinarily cheaply and extraordinarily fast because it's all sitting on AWS and it's all sitting on a compute system. So what this meant was we were able to start with very little from the XView real data sets. We were able to create synthetic data only and combine it. Whoa, some of the numbers doubled, some of them didn't double, but some of them moved, and we went, that's interesting. I wonder what would happen. And then the next experiment was, what if we combine synthetic data with real data and see what happens? And that's a threefold increase based off an extremely low floor, an improvement in terms of average precision score in our training set data. So this is the power of synthetic data. This is a tremendous proof source. And as I mentioned before, happy to get a white paper to you on this particular engagement so you can read up more. Next. So this kind of circles back to where we began, and that is the synthetic images off of our platform. That our platform has this amazing diversification that you can build scenarios, and you can have applications that are different and as different from a medical imagery to skin. We have people creating artificial bocce ball representatives. If you look in the middle, those are actually one RGB slide and one IR slide of exactly the same graph that Dan had set up there, so that you can see what it looks like under two different sensors. We do a lot of SAR work. We do a lot of work with multispectral. We do a lot of work in different kinds of backgrounds and environments around the world. And that we have a growing and wide coverage of different application zones that help you get started in these particular areas. So how do you get started? Dan has alluded to this. Hira has alluded to this. There is a, hey, is this right for me? Try it, buy it, kind of, let's figure out the toy box. The toy box is actually extraordinarily realistic. It's all physics-based. You have every drop is different from every other drop. You can obfuscate different characteristics in it. You can integrate it with different pipelines. You can create data sets. You can begin to doing masks and annotations. The point is, you can say, is this a tool that could be useful to me? Doesn't cost you anything. It's great. So if you say, yeah, this tool could be kind of useful and fun, maybe I should develop this, or maybe I should subscribe professional services with Rendered.ai, like we did in the Orbital Insight thing to develop the application. But either way, the next step is to develop the application. So we have a subscription level there in which the monthly cost is $500, and in that you're building that graph that Dan was showing you. You're doing that node and edge connection in order to say, is this useful? Is this useful? Is this useful? Ah, this was actually useful. So now I have something, and then I move to the professional subscription level where I say, I'd like 100,000 of those, please. And you push the button and you get 100,000 of those images. So it's all tiered to say, moving along in a process here that starts you out at a basic subscription, going to a developer subscription, and then going to a professional level. Hira?
If you're
Muted, Hira.
how to generate your If you're curious about how to generate your very own data set, sign up to access our platform through this QR code or the link on the page, which I am going to put in the chat right now. In our example channel, you can generate a synthetic data set of toys, just like the background of the slide that you're looking at here. And also, quick note, please come visit us at GeoInt. We're going to be at booth 835. We will have a tutorial featuring Dan Hedges, who you heard from earlier, alongside our COO and head of product, Chris Andrews, and that's going to be on April 26th at 7:30 a.m. And then later that day, we're going to have a lightning talk by our CEO, Nathan Kuntz, and again, that's April 26th at 3 p.m. And in behalf of our tech partners, we'd love to thank you for joining us for the session today. We'd like to connect with you on social media, so you can find us at Rendered.ai. Now we're officially on to the Q&A session. Please feel free to ask any questions that you might have, and I can also unmute everybody so that you guys have the option to speak those questions. Okay, cool. And now everyone's mics should be allowed to share if you would like to unmute yourself to join. And you can also put it in the chat if you want to as well.
So Hera, if I were to get new models, how would I go about getting new models for my system?
Dan, do you want to answer this question? Sorry, I'm just working on.
So we have a variety of different channels that we've developed that kind of get you to that 80%. So like Tom said, every computer vision problem is different, but we have some sort of basic channels that we've developed that we can deploy to your channel and allow you to kind of get started with these specific applications.
You kind of made an interesting announcement there about DeerSig on the platform. Can you add some more color to that?
Yeah, so we're integrating with DeerSig. That's a remote sensing simulation tool set that is put out by the folks at RIT. So we're working on building an example channel that allows you to be able to do that. It's like I said, it's a very high fidelity, high complexity model that if you want to really get into the weeds about how you're generating your remote sensing data, then that's a good way to go.
There is a question in the chat, which I'm going to just, yes, we will be sharing the recording in a follow-up email. And someone's asking if we can further explain the platform as a service concept.
Yeah, so if you think about Salesforce, it would be possibly the most famous platform as a service out there. No two people's customer management record systems, which is what Salesforce is, are the same. Every enterprise has a different slant on the problem. They're all generally, we got to figure out who's out there, where they are in the pipeline, what is likelihood to close, when they're going to close. So Salesforce has created this platform as a service, which says we have all these stumped out ends that integrate with all these other enterprise data flow situations, and that we have all of these user interfaces that are already sort of an 80% solution. It's a good way to think about it, an 80% solution. We at Rendered.ai are doing the same thing, but for synthetic data. So that we have this platform that says, we know about models, we know about obfuscation, we know about the wash, rinse, and repeat process of sending this through our loop in order to get better. We know about the AI models. We know about all the important touch points, but that you might want to have a situation where your touch point, we actually know this, no two applications are the same, and that you're going to be wanting to have something subtly different. And as a platform, you're able to do that. Did that help answer that question?
Yeah. So Tom, if I can build off that a little bit. So one way to differentiate from a software as a service setup is, we're providing the software, the web application, but also the ability to customize it. So that sort of developer workflow to be able to tap into how to customize our software to be able to make it work for you. So that's another way we're kind of defining it as a platform, you know.
Yeah, there's another important point there that you touched on, which is just abstracting away all the confusing compute and librarianship and all the sort of utilities that make synthetic data successful is sort of suppressed and under the covers so that it can be accessed when necessary, but you don't have to deal with it in your face.
Cool, thanks. Someone else is asking, can you elaborate on the types of mods and partners you're looking for?
Yeah, so we're kind of partnering with the best in the industry in all these different areas. So if you know, if you have a simulation tool that you know, solves a problem, we'd like to talk to you. Like we said, kind of the ability to have flexibility is really important to our users, and it's important to anyone that's generating synthetic data, especially from a, you know, a computer vision standpoint. You need flexibility to be able to accurately simulate your modeling, your sensor. So yeah, we'd love to talk if you are a simulation provider. But you know, aside from that, we are growing the list of partners that we work with every day. So
yeah, and someone asked if I can share the white paper reference by Tom in a follow-up email. And yes, we would be happy to. We will be sending that over shortly after we get off this call.
Dan, could you talk about Esri's ability to have 3D examples of the world anywhere in the world? Do I understand this right?
So Esri is a company that I worked for a number of years, and it really has a wide variety of different data, you know, authoritative data within their Living Atlas. So we've built out a channel that allows you to pull from image services and map services to generate those backgrounds, kind of like what I showed in that demo that I gave today. If you have discrete locations of different types of areas that you want to simulate, and you've got a map service or a service that's provided by Esri's Living Atlas, you can plug that in and have your set of image chips that you can use to place your objects in with. So that's kind of what we're focusing on at building just at the moment. So it's kind of a very basic application of being able to pull those image chips for simple backgrounds. There's also a lot of 3D capabilities that Esri provides with City Engine and things like that. So in the future, we may look into doing that as well.
Could you talk a little bit about what the usefulness of SAR is as opposed to SAT-RGB and the
I'm gonna quickly interrupt you just because somebody else had a question in the chat.
question as opposed to mine. Fantastic, good.
Yeah, let me, Peter, we will connect with you afterwards. We'll just, do you want to drop your email in the chat, Dan? And so Radha's asking, thank you for your answer. Synthetic data has been a hot topic and many companies have just considered building basic generation and labeling operations in established engines such as Unity, Unreal, etc. It seems those companies might be giving up the generality offered by those platforms by going to the Rendered.ai platform. How does your platform compare to the general applicability of popular game engines?
Yeah, so I think that is best defined as, you know, this is a platform created, purpose-built for synthetic data, and you know, you're not giving up the generality of these different game engines because you can plug in with them, right? We're working on an Unreal Engine plugin for generating synthetic data. So you know, we have a variety of these different types of simulation tools that we're partnering with, that we're developing in-house as well. And then on top of that, you've got all the other pieces, the domain adaptation, the quality assessment and the scene building things, so I'd say, you have the generality that comes with these different types of game engines, but also the ability to use more tailored simulators, and I'll have that within a platform that manages compute and things like that.
When you start with CGI, you tend to get clones of CGI. You have to be careful about that. And when you start with a physics-based system like ours, you actually end up with original material, because it's an original model that you are creating and morphing off of. So to Dan's point, we don't see these things as being mutually exclusive. We see them as being complementary technologies.
Great, and yeah, happy to continue this conversation. I dropped my my email in the chat there. If anyone has any other questions, you can either type them or speak them. But yeah, if not, thank you for joining. This has been great. Been good to speak with you all, and hope you got some value from this.
Thank you again.
Yeah, thanks so much for joining. So hopefully we see you guys, requesting access, and we'll definitely be having some more webinars in the future. So definitely look forward to that as well.
Cheers.
Thanks.
Thank you.
Thank you.
Thank you. Have a nice day.
You too.
As well.
Much.
Thanks.
All right, I got to jump here.
All right. Thanks, Dan.
Thanks.